Thank you for the introduction. My name is, as you said, Noah. I should flip this. So, I'm going to talk about production engineering and hopefully be able to answer the question, what does it mean to be a production engineer at Facebook when this is over? And where does production engineering fit into the larger engineering picture at Facebook? And what's the history that made us come up with this naming, and how did we end up where we are now? So, my name is Noah. I am a production engineer here at Facebook. I've been here for since August. It's to the day 1 year since I set my foot first in this office. I was here for a day of interviews, and it was exciting. And when I did go out of the door after a long day, it was very tired, very excited, and not at all sure that I would get an offer. It felt like I was mangled. But apparently they wanted me, so here I am. I've been working at Facebook for a little bit, but I've been doing sysadmin work for a very long time, and I've been doing development work, writing software, building websites, and those kinds of things for many years. I also want to say that I understand that Facebook is fairly different from many other organizations. We have, it's larger, we have a different history than many others, but hopefully there will be some things that you can learn from, and at least some fun stories, and maybe a little bit of advice that might be useful. So, what is a production engineer? A production engineer is a mouthful. A production engineer is a software engineer / systems engineer / network engineer. And the slashes in this context are kind of additive. So it's like all of these things, which is a bit strange. I have done some talks at DevOps meetups and conferences for a few years now, and I typically give people the advice to not hunt after the unicorn, trying to find the person that will fill all your needs, not try to find the person that has these overlapping key competencies, because they're so hard to find, and you're better off spending time aligning your incentives and making sure that the people you have work towards a common goal. Maybe I should stop saying that, because for some strange reason, it seems like a lot of my colleagues are these unicorns. So I don't know, but yeah, it's fun to be here, and I'm really happy to have the opportunity. Of course, having the exact right mix of experience and knowledge is not, it doesn't really matter. Some problems are just larger and more difficult to solve than can be solved by pure experience, and we need to think about how we organize. So that's what I'm going to talk about here. So how did it start? I think that you can recognize a lot of things with how Facebook started. It was like a founder sitting in his room, writing PHP code, putting his data in a MySQL database. Not what I would advise, but apparently it worked. And it grew very much organically from there, and it wasn't such a big plan. It wasn't a plan to build a company with thousands and thousands of engineers to solve really, really difficult problems, but it was something just sort of happening. And that's, I think, how many different organizations grow. And you get a few customers, you start hiring some more developers. After a while, it makes sense to hire someone that is good at unpacking computers and putting them in racks and flip switches and install operating systems and those kinds of things. And all of a sudden, you have a development team and an operations team. And it's a very common story. It's a bit of an anti-pattern, I think, but that's where we ended up. And I think that's kind of where things diverge a little bit with regards to Facebook. It turns out that this idea of connecting people, so this image is an image of the world, but it's also an image of Facebook users and their connections. So the dots are Facebook users, and the connections are lines, and many connections equals many lines. And you can see that it's something that grew more than anyone could have anticipated. And it means that the pressures on this traditional structure of having a dev team and an ops team was kind of like, it was difficult from the beginning, and it kind of got worse in a bit. So one thing I've noticed when I started working at Facebook is that people are generally very helpful. They are easy to approach. They will try to solve your problem if it's reasonable for them to do it, if they know, or they can point you towards someone that knows. And that's a very, very useful thing. And I think it's one of the success factors of Facebook as an engineering organization, to be able to help each other out when it's needed. It is also a bit of a problem, because when you grow the organization, there is a lot of firefighting going on, and there is a lot of things that break. And fixing problems in this very informal way of working is a lot about knowing the right people, knowing who built what, knowing the history of something. And the informal knowledge that you needed to be able to solve problems circa 2011, maybe 2010, was a lot about who you knew, who has built something before, who has the right phone numbers in his phone to be able to reach out to the right person. And that's really nice, and it works really well for a surprisingly long time, but at some point it breaks down, and you need to figure out some other way of doing things. This is especially true if the complexity of the systems increase, and when you grow a lot, you buy a lot of hardware. Facebook got some money really early on, and they bought data centers, and there were thousands of computers, and it's even more difficult to do that when complexity of the systems grow. So there was chaos, and I'm told that this is artwork that exists in the office of Jay, who's the director of infrastructure at Facebook in Menlo Park in California, where the head offices are. And he has this saying on the wall. When I saw it the first time, I thought, like, yeah, all great things are preceded by chaos, maybe, but chaos is pretty painful, and not all changes are great, so I'm not sure about that. But sometimes it's clear that you need to make a change, and at Facebook, that sort of awareness that something needed to be radically different with regards to how we organized operations was around 2011. And what happened then was that we kind of developed from single question, which is, if there was no operations group, if there was no team to work and running the service, what would we need? What would we build? What kind of organizational changes do we need to enact to be able to handle that transition? And it's a really scary transition, especially if you have these people with a lot of phone numbers in their phones, to be able that knows exactly what to do when Memcache is dying or MySQL is acting up. So this change was scary, and obviously a lot of things needed to change for this to be able to become reality. But there were technical things that needed to change, and I'm going to focus on two areas. Obviously there are many more things, but there are two areas that I think are interesting to look into. And the first one is automation. We all know that humans make bad robots. Like, people get tired. When they get tired, they make mistakes. They want to have fun. They can't work for many, many hours. They get bored. They want to have afterworks and beers and stuff. It's super complicated. But computers are really good at doing things over and over and over and over again. So automation is something that helps you do the things that are more fun, more productive, and more useful to the organization. And we have a lot of automation for various things. One system I would like to talk about is the Facebook Automatic Remediation System, or FBAR. So this is a system that responds to alarms, and it does various things. And it's built on top of all these APIs that can do various things in the real world. So there is an API to flip switches, like the hardware power control API. There is monitoring to figure out whether the service works or not. There is an API to open a ticket with the people working in the data center, to replace hardware, those kinds of things. This system is powered by remediations plugins, which is code that responds to a specific alarm. And like the canonical example of this would be in a sort of a computerized version of, have you tried turning it off and on again? So you can write code that concludes that, oh, this is broken in some way. We shut down the service, we try to shut down the computer. If it doesn't respond, we connect to the hardware, the power switch in the rack and flip the power switch for the service. And then hopefully it comes up after a while and we can test it and verify that, oh, yeah, this is fine, it's back. And you can do this over and over and over again. It's surprisingly useful. It's also good to keep track of how often you do it because like, it's good to know. But it's a very, very useful system and it's used today at Facebook. Another really important change was to increase observability. If you have a single server and you don't know what's happening on the inside, you don't know how things fit together, and you don't know like if it's feeling good or if it's feeling bad, then it's very difficult to sort of do anything useful as an operations person. And this problem gets worse as you have more computers. If you have 1,000 computers, it's probably impossible to do anything useful if you're not tracking what's happening on the inside. So observability, being able to look inside what's happening in your software is super important. We have a system called FB303. So backend services at Facebook provide typically a thrift interface that does something useful. It might retrieve something from a database, or it might write something to another thing, or do some computation. And then there's an add-on additional thrift interface called FB303 that has the ability to expose counters and numbers. So in your code, you could add a few lines of code to say like, yeah, I served a response, I got an error. This took so long, this took maybe too long, and I'm gonna increase the warning counter for a little bit here. And these numbers gets extracted using something called FB Agent, which is a small piece of software that runs on every server as well. And then it pushes all these numbers into the operational data store, ODS, which is a very large system to crunch these numbers, add up the sums, create beautiful graphs, and also create alarms. So ideally, it should be very, very simple to add really powerful metrics to your software and to be able to get numbers about how your software is doing. And then you can both have a visual look at trends, see like, oh, things are going progressively slower and slower every night. This is taking longer. What's up here? Like something is happening at 3 o'clock. We need to figure what is out. You can look at whether things are happening at the same time. Like, is there some sort of connection between this that happens here and this other thing? And also creating alarms. Like if this is over a certain threshold, then do an alarm. And then you can have FBAR come in and restart the server. Or like maybe it's a bad example. We can do more advanced stuff on resorting servers, I've heard. Anyway, it's very important to invest in observability and figure out how things work out. And all these changes were kind of preparing us to move into this brave new world where each team were responsible for their own service. Each team were responsible for running the software that they built, and changing that from having a centralized team previously called AppOps, or application operations, was a huge step, but it was taken in 2012, and we created something of a rebranding to the function that previously was AppOps and turned them into production engineering. So production engineering, why do you pick a new name? What did we want to say with a new name? So I think that the most important thing was to say, we're not operations. We are not the people that run your service. We are not the people that fix the problem when it happens. We will work on these solutions, these tools that are needed to be able to run the service, but we will not fix your problem. And also, we wanted to convey that this is part of engineering. This is not something separate. This is not like something that exists outside of the larger engineering organization. But we are together in this, and we work together. And this is software development, typically. So production engineering was built, and also it was a little bit about branding. It was about building an identity as a group, understanding and making the rest of the organization understand that we have some skills that are very, very useful when building a service at scale. So it's kind of a PR thing as well, a little bit. But I think that that is important. I think that it's important to recognize when people are amazing. Sorry. So at Facebook, there are two types of engineering teams. There are engineering teams, org charts. Some people think they're nice, so enjoy. The simple case here is the PE team that is just production engineers. And they are typically responsible for things that are pretty low down in the tech stack. They work with provisioning. They work with installing the base operating system. They work with configuration management, kind of very hands-on things. And fairly far away from the actual service that people see. And they build it and maintain the tools that are needed for other teams to be able to do their job. And they are organized pretty much like ordinary teams. The more interesting case, and a team like I am a production engineer in a team called Scribe, and we are what's called an embedded team. So here in London, we are 4 production engineers working with a bunch of software developers on a system called Scribe. So it's a distributed message bus type thing, and it's a lot of overlap in the things that we do with production engineers. With software engineers, or SWEs as they're called here. We share our on-call, we share meetings, we have a lot of in-depth discussion about where our product is going, what things we need to build to be able to continue to scale, those kinds of things. But there are also differences between what the production engineers in my team are focused on as opposed to the software engineers. So we bring something special. And to be able to describe that in a little bit more detail, I have what's called a service pyramid, which is sort of a slightly formalized way of thinking about what production engineers are doing and should do in a team. So this is something that is somewhat akin to the Maslow pyramid of needs. So, like you need food and sleep and security, shelter, like things, very basic things first, and then once you have that, you can focus on more fun stuff. But like, the fun stuff isn't really fun if you don't have food, if you can't sleep. So the point here is that if you have a service, if you have a team, the production engineers are there to push your service up towards the top of the pyramid and do successively more interesting and more sort of advanced things. So it all starts with servers and provisioning. You need to have servers to be able to run. Otherwise there's no meaning in anything else. So I guess the initial focus typically is to make sure that thing works. And then as you progress, you start looking at monitoring. It's fine initially to just check if the service works and just be happy with that. But as you progress, you want to keep track of whether your servers are up or if they're broken, and to be able to handle that. And then as you progress in monitoring, you're moving upwards in the sort of food chain, as it were, and have successfully more advanced and sort of higher level metrics about how the service is doing. So looking at application level metrics and monitoring the service as a whole. And once you have that, you can look into automating and building your service around clusters and concepts of sort of discrete pieces that you build together to build the service. So our team has a bunch of different clusters living in different data centers in different parts of the world. And if we have a problem in one cluster, we can take it down, and we can move traffic around. And having larger building blocks than servers is a very useful concept, and being able to move towards that is very valuable. Obviously, the fun stuff is in top of the pyramid, so it's like, yeah, pyramid of needs is like music and self-actualization and stuff. But in this case, it's like the 1% stuff, the really strange failures and errors that you don't have time to do otherwise, performance tuning, those kinds of things. So production engineers exist in the organization to push services up towards the top of the pyramid. And sometimes we're far up towards the top, and sometimes we are at the bottom. And then we do different things in the teams. But we are working and trying to nudge the software development teams and do work ourselves to push ourselves towards the top. So that's a little bit about what software engineering is. I would like to end this by giving some advice, try to give some advice. And I think my first piece of advice is best illustrated by this. So focus on automation. I don't think I can overstate this. So it says, I find your lack of automation disturbing. And automation is, like, it's the key to be able to scale beyond a certain size. It's not possible throwing humans and hire enough people to run a really large-scale service. You need to have software doing your job. And for us, this has some implications. It means that to be able to be a production engineer, you need to be a software developer. It's not enough to be able to put together some shell scripts that does things like from top to bottom. You need to be able to design software. You need to know a few programming languages and be able to write code with some confidence to be able to do this. And I think that being able to recruit people from the group of like has gotten and has some passion about writing software has so much value when it comes to the types of solutions that come out of whatever you do. You figure out things that you didn't think was possible to automate. And I think that that's something that can be used everywhere. Hire programmers and learn to program. So that would be my first piece of advice. My second piece of advice is we need to get away from, like, I think this is a challenge even in an organization like Facebook where we have embedded production engineers in the teams, that we don't get the divide where production engineers are separate when they do separate things. We need to be involved in each other's things, and we need to understand what we're doing, explain what kind of problems we run into, and work together to form a team that has a single mission. We want to have this service be as good as possible. We want to build the features that makes it possible to scale, and we want to build a service that is really, really reliable. And getting everyone on board on this is very, very important, I think. So that would be my second advice. My last advice has to do with fear. I think it's very easy as a person that works with operations type things that cares about quality to be afraid of things. Have you done some stupid things? I remember when I was 19, 20 maybe, and I didn't really test my backups before the hard drive broke, and I broke things, and we lost data, and it was terrible. And I didn't sleep so well. And it's so easy to let those types of experiences shape you and make you act out of fear. And then you avoid things. You walk around like you never do failover with a database because, like, yeah, that might do something bad. And then you wait and wait and wait. And you never release, or sometimes you do need to release software, but maybe it's 6 months and then you release a new piece of software. And you end up in a situation where you're afraid of things. I think that we need to sort of meet those things that you're afraid of head on. If you're afraid of releasing new software, then you need to build automation and find tools that can help you release really often so that you become really good at it. And also that it's really important, I think, to learn from the mistakes that happens. And that's a tricky thing to do. I think that at Facebook we are doing a good job, not perfect, but we're doing a good job with figuring out what fails. We have something called SEV review, which is every time something happens that has negative impact on someone in the organization or end users, it's called a site event or a SEV. And every Friday morning there is a SEV review, and the things that have been significant enough during the week or the week before gets into SEV review. And then you have a discussion about what failed, why did it fail, what can we do about it? What things do we need to change for the next person that comes along and does the same thing, so that that person is not doing the same mistake, or so that it becomes easier to do the right thing and more difficult to do the wrong thing. Spend time with remediations and those kinds of things. I think that those two things, building software that helps you do the things you're scared of and do it more, and also in a structured way try to learn from your mistakes. And obviously it's no good if you're blaming the person that did the mistake. It's an organizational problem when something breaks, and it's something that the organization needs to take responsibility for. I think that's a very important thing to think about when you do engineering. That was my talk. Thank you so much.
No, excellent. Thank you very much. Take a couple of questions?
Sure.
Cool. John.
Can you pull up your pyramid again? Your
What?
pyramid. Can you pull up your pyramid slide?
My pyramid slide, I might be. I have a back button here, so.
Perfect.
There it is.
Perfect.
There.
So perf tuning is right near the top. I'm curious why. I mean, performance seems like an afterthought. What do you think? Is there a reason for that?
I think that obviously many of these things blend together. I think that this is about like the main focus of things. But I do think that. I think that sometimes it's easy to optimize prematurely as a developer. You think like, oh, this algorithm is much smarter than the other one. Maybe it doesn't matter. Maybe you're too early on that. I think that looking at making sure your software is rock solid, and I think that monitoring and sort of automating the steps to be able to turn up your service, turn down your service is more important. Obviously, if you have thousands of requests per second, you will go into perf tuning mode because it doesn't work otherwise. You can't bring up the service, so you get there. But it's I think that to my mind, it seems like we are doing performance tuning a bit too early sometimes. So that's my subjective view.
Good question, John. Thank you. Ben, I think you had a question?
Cool. Hey, so I love the idea of cross-functional teams, software engineers working together with the production engineers. What do you do, though, when a product kind of comes out of a development cycle or it goes into like a BAU stream and it's not being worked on so much? How do you still keep those people on support whilst working on other products? How do you scale that?
I'm not really sure. I think that there are people on the panel that are much better at doing that. I pretty much have been in one team, and we haven't really worked on that.
I work in consultancy, and lots of clients would love to be able to do this. I haven't seen it scale yet.
Yeah, it's a challenging thing. I will dodge that question. I hope that is okay.
Nicely done. We'll pick that one up later. Alison?
You mentioned SEV reviews, or wash-ups, as the rest of us know them as, and you also mentioned not being afraid. How do you stop people being afraid of the SEV reviews?
Yeah, I think that it's an important thing. I don't think that there is a good answer. Like if you take some not be afraid spray and you spray it over everything, then it works out. I think that it's about hard work and talking about like this might feel scary, but we are not here to hurt you. We're not here to put anyone responsible, crucify anyone in this process. We're here to figure out what went wrong. We're here to improve, and I think that that's something that you need to be aware of and work really consciously with. But otherwise, I don't really have a good strategy other than that.
Cool. Question over here now.
Hey, just a quick question really about the cross-functional teams. Do you do any kind of pairing, and would you sort of advocate that as a principle to get people from different disciplines working together to try and share that knowledge and mostly share the ownership?
I would. I think that it's a very useful thing. One thing that has surprised me a little bit when coming to Facebook is that so many things when it comes to sort of the micro-engineering practices, how teams work together, how do you do planning, how you work, like, do you work in sprints, do you have some visualization? Those kinds of things are up to the individual engineers. There is no enforced way of working or enforced way of doing pairing or anything like that. So it's pretty much up to the organization to figure out how to do that. I think that it's a very good idea, and I try to do it in my own, like, trying to nudge people towards that, but it's not something that Facebook in general, I think, has as their sort of a tenet of how we're working or anything. It's interesting that chaos works kind of well. I don't know how it works, but
We love a bit of chaos. Question over here.
How does the operational overhead of running a service tend to divide between the production engineers and the software engineers?
I think it's different. I think that in different teams, but I think that the production overhead is kind of tied to how you do on-call and how you work with the sort of list of things that you need to keep track of as a team, and how the interfaces look as a team. And depending on how you construct that, I think that, like, in my own personal experience, we've been fairly good at making sure that that work is evenly divided, and that you're sharing that around the team. But I could definitely see how it might break down and be very even, like, one-sided, and that's something to look out for.
Great, got a question down here on the end.
Very simple questions. Which programming language are you comfortable with? And if I may ask a question about Facebook, how many software engineers have we got here? If you don't. Thank you.
The first question, I personally am comfortable in Python and Java and C++ a little bit, and that's plenty here. It works well. It turns out that the chaos of having a lot of engineering freedom is that there are a lot of languages being used. The main website is built in this PHP type thing, which is called Hack, which is essentially PHP plus typing plus some synchronous niceties plus performance, which is hard, I think, from my perspective. But in general, Facebook production engineers work a lot with Python. Some work with Go, some work with other fringe languages, and then it's good to have some basic knowledge with the language of the service you're working with. In our case, it's Java and C++. So that works out. How many software engineers there are at Facebook? The PR department is kind of sensitive with regards to numbers and stuff, unfortunately. So thousands, I think.
Okay, cool. We've got one here.
Hi.
Hey.
So, quick one. We're talking about the server or say hardware services monitoring lifecycle. Where does the DevOps or the build engineering comes into play? Who manages that? Is it the software engineering team, or the production engineering team has a safeguard there that these are the set of tools that we will use in terms of build engineering, and how do we manage the drift? If, as you said, we've got engineering independence, people are using multiple languages. So how do you manage that drift in terms of tooling that they require?
Not totally sure I understood your question, but like when it comes to what software developers do versus production engineers do in a team, I think that it's instructive to know that a lot of teams that run services stuff doesn't have any production engineers. So production engineering is something you sprinkle on top. There is probably more than 10 software engineers per every production engineer in the organization. So it's something that, like all these things you need to do as a software engineering team. And then sometimes you have production engineers that come in when your need is big, or when there are some special reason for your team to have a production engineering presence. But in general, it's something that's driven from software engineering in most cases. I'm sorry.
Okay,
Yeah, we can talk later, maybe.
Talk later.
Yeah.
Okay, great talk, great questions, great answers. Big hand from Noah, thank you.
Thank you.